All right, good morning, everyone. It's week 7, and this is classwork 17 honors. Today we are starting a new unit on probability and statistics, okay? So what we're going to start off with is two-way tables, and this should be something that you might have done in 8th grade or Algebra 1. So our objective today is to calculate relative frequencies using two-way tables. So we're going to go over what our relative frequency is, some other vocabulary, and then we're going to start with one-way tables and work up to two-way tables. Okay? So I'll explain all that in a second. Let's start with some quick vocabulary. First, a sample is going to be the people or objects that we're looking at, right? So this is individuals or objects used in a study. And this is only a part of the population. So maybe we're only looking at, 100 people in Maryland, whereas the whole population of Maryland is much larger. So the sample is just whoever we're looking at. It might be small, it might be big. The frequency is going to be a number. Sometimes it's the number of times an event occurs. It could be the number of people who vote a certain way, okay? So the frequency is some number. Now the relative frequency is going to be a decimal, and we're going to find that by dividing the frequency of one category or maybe multiple categories divided by the total number of people or objects in the sample, okay? So it's a frequency number divided by a total number. And since the total will always be bigger than, the number of times in one category, this will always be a decimal. And we'll talk more about what that means later in the lesson. We're also going to be using tables today, which a table is just going to be a tool to organize data. Okay, so we're not using our tables as X and Y intercepts, nothing like that. We're just using a table to organize our data. Okay, take a second, pause the video if you need to write this down. I'm going to be starting example number 1. So, for number 1, there's a survey with results as follows. 30 students prefer chocolate ice cream, 25 students prefer strawberry ice cream, and 27 students prefer vanilla ice cream. So in this survey, students were only allowed to pick one ice cream, and what we're going to do is we're going to fill out this table so that we have a nice organized set of data. So the way I read this is ice cream flavor goes across, and the number of students will go across. So the first box will be the number of students who voted for chocolate ice cream. So if I go back to my data, 30 students prefer chocolate ice cream. Then the number of students who prefer strawberry will be 25. And the number of students who prefer vanilla is 27. And now I want to know the number of students in the total. So how many students were there that participated in the survey? That would be our sample size, right? How can I find that out? We should be adding. If we add our categories, the number of students in each category, we should get the total number of students that were surveyed, okay? And that's also going to be our sample size. Okay? So, now we're going to fill out a relative frequency table. So this relative frequency, before we said frequency over total, this is just another way to say that. And we also know that the total number of observations is that sample size. So in this case, we know that the total number of observations is going to be 82, because that's our total number of students. So, for each category, we're going to take the number of students and divide it by the total number of students. Okay? So, for chocolate, to find the relative frequency, I'm going to take 30, the number of students who like chocolate, and divide that by the total. So this is the frequency for chocolate divided by the total number of students surveyed, okay? and I should get a decimal. So when I do that in my calculator, 30 divided by 82, I get 0.3658. So I'm going to round this up to 0.37. All right. So for strawberry, I'm going to take the number of students, that's the count for the category, or the frequency. The frequency for strawberry is 25. I'm going to divide that by the total, which is 82. All right, so I'm going to do 25 divided by 82, and I get 0.30 if I round to 2 decimal places. Okay, and now for vanilla, I have 27 divided by 82. So I'll get 27 divided by 82 is, if I round this up, 0.33. Okay, now my total relative frequency can be the added number here, but it should also be 82 divided by 82, which is 1, right? 82 divided by 82 is 1, but I should still get 1 if I add up all my previous relative frequencies, okay? So 0.37 plus 0.3 plus 0.33 is 1, so that's perfect. So our total relative frequency should always be 1, because each relative frequency is a part of the whole, right? So these fractions, each of these numerators would add up to 82. And the denominator stays the same. Like when we're adding fractions, we have that common denominator. Okay? So the relative frequency is really telling us that this is the proportion of students that like chocolate ice cream. And we can express this also as a percentage. We could say, okay, 37% of students like chocolate ice cream. Okay, so this is how we do this for the one-way table. I want to talk about now how to do this with a two-way table, okay? So real quick, a one-way table is there's only one variable, okay? So our variable here, the thing that's changing, right, is the ice cream flavor. So a one-way table, this is a one-way table, has only one variable. So I should have mentioned that before. But this is a one-way table because there's only one variable. There's only one thing that changes. Now we're going to look at a two-way table that has two variables. Okay? So now you'll see that we have a very similar table. We're still doing ice cream flavor, but now we also have gender. Okay? So this is a two-way table. And it's a two-way table because there are two variables: ice cream flavor and gender. Okay? So now our survey is telling us of the 30 students who prefer chocolate ice cream, 22 are males. Of the 25 students who prefer strawberry ice cream, 15 are females. And of the 27 who prefer vanilla ice cream, 13 are males. Okay, so we've got a little bit more information that we need to substitute into our table. So let's start off with, of the 30 students who prefer chocolate ice cream, 22 are males. So we know if we go to chocolate and male, that should be 22. Okay? So we read it like this. We have chocolate, we have males that like chocolate, females that like chocolate, and then the total number of people that like chocolate, or students that like chocolate. So how many total students like chocolate ice cream? 30. Okay, so that's the same number from our first table. So if 30 students like chocolate, 22 of them are male, how many of them are female? So what we do to find this female box, we should be doing 30 minus 22. And actually, I'm going to write that in a different color so it doesn't stand out as much. So 30 minus 22 will be 8, right? So we have 8 female students that like chocolate ice cream. Let's do this same thing for the strawberry. Of the 25 students who prefer strawberry, 15 are female. So we know 15 students who like strawberry ice cream are female. So I'm going to female and strawberry ice cream, and that number is going to be 15. And how many total students like strawberry ice cream? 25 students prefer strawberry ice cream. So I'm going to put 25 here. So if 25 students like strawberry ice cream, 15 of them are female, how many students are male that like strawberry ice cream? What I'm going to do is 25 minus 15, which will equal 10, right? So we should always have our total for the column be the sum of the columns above, right? So 10 plus 15 equals 25. Good. 22 plus 8 equals 30. Perfect. And then, like before, our total for the row will be here. Okay, so let's finish with what we know first. 27 students prefer vanilla, 13 are male. So for vanilla, how many are male? 13. How many total students like vanilla? 27. So then how do I find the number of female students? 27 minus 13, which should be 14. Okay? So then we should check this. 13 plus 14 equals 27. Yes. Now I can figure out the total number of male students and the total number of female students and the total number of students in general. So to do the total number of male students, I'm going to add 22 plus 10 plus 13. That should give us 45, right? You can check that in your calculator. So this was 22 plus 10 plus 13 gave us 45. Then we'll do for female students 8 plus 15 plus 14. And that should be giving us 37. Oh, sorry, 37. And then our total, which should be the total of both these two rows, right? 45 plus 37 is 82, which should also be the total of this row here. So 30 plus 25 plus 27 equals 82. So our total, this is our total number of students. Okay, our total number of students is here. This was our total number of males. This was our total female. This was our total chocolate, our total strawberry, and our total vanilla, right? And then the total is 82. Okay, so now when we go to the relative frequency table, we're still using relative frequency, which is the number here divided by the total number, like of the whole sample, okay? When we do a relative frequency, we have the total of the whole sample is what we're dividing by. So when I complete this table, I'm going to take 22 and divide it by 82 for this box. So 22 divided by 82 will be, and they're all going to be decimals, right? 22 divided by 82 is 0.27 when I round, and I'm always going to round to 2 decimal places, okay? So we're going to continue this for the entire box, for the entire table, okay? I'm taking all my frequencies and dividing them by 82. So for strawberry, for men and strawberry, that's 10 divided by 82. Vanilla and strawberry, male and vanilla is 13 divided by 82. total percent of males is 45 divided by 82. And we're going to keep doing this for every single box. Okay, so I just did a couple of my fractions first. And I'm going to pop these in the calculator. And you should be doing this with me. Okay, and then I know from my previous table that these are going to be and now that I have these, I can fill in the other bits by doing subtraction again, or I can do 8 divided by 82 and get 0.1 that way. But there's always more than one way to do this, right? So I can get 0.09, but it should be 0.10, right? Because 0.27 plus 0.10 would give us 0.37. So these numbers should still add up correctly, okay? And then I'm going to take 15 divided by 82. And I'm going to get 0.18. And then 14 divided by 82 should be 0.17. And then finally, 37 divided by 82 should be 45, right? Because that's how we need to add up to 1. Yes, 0.45. Okay. So, I've completed my relative frequency table, and you're going to be doing this as well in the classwork. So remember, we're just doing the number in the, this is a frequency table, right? So we're taking the frequency and dividing the frequency, each frequency by the total, okay? All right, so now we have these discussion questions so we can really analyze this data. So I want to know how many, what is the proportion of students who prefer chocolate ice cream? So I'm looking for the total number or the total relative frequency of students that prefer chocolate ice cream. Not male, not just female, but all students who prefer chocolate ice cream is going to be 0.37. Now, we're looking for the proportion of students who are female and prefer vanilla ice cream. So I'm going to go to female and vanilla and look here, and that's 0.17. All right. Number 3 is write a sentence explaining the meaning of the approximate relative frequency of 0.55. So what this means, 0.55 in this table, I'm going to look for it. It's right here for male. So what this means is that approximately 55% of students in the study were male. And I know that because this is the total number of male, the relative proportion for the male students. Okay, so if I compare this to my my frequency chart, I know the total number of male students is 45. So this relative frequency is the proportion which can be expressed as a percentage of students that are male. So if it's a relative frequency of 0.55, I can convert that to a percentage of 55%. Okay, please, please, please contact me if you want any more clarification on that. But really what I just did is multiplied this by 100. Okay, just like when we were working with rates in the previous unit. All right, so I've got one more example for you all, just so you know exactly how to do the classwork. Bear with me. I know this is a long lesson, but it's important that we do all this so that you do well on the classwork, okay? All right, example number 2 is a random group of students are polled about how they get to school. The results are summarized in the table below. So we have a couple different transportation modes. We have walking, bus ride, carpool, and then we also have male and female for gender. So this is a two-way table because there's two variables, gender and type of transportation. Okay. Number 1 says, calculate the relative frequencies for the table above. Write them as a percent in each cell of the table. Round them to the nearest tenth of a percent. Okay. So, since they want us to calculate as a percent, that means whatever we get for our relative frequency, we're going to have to multiply by 100. Okay? So, again, to calculate the relative frequency, I'm going to divide the frequency here by my total. Okay? So, my total is 102, which means my percent here, my percent for the total is always going to be 100%. Okay? Or, like you saw in this table, we had 1.00, which, if we converted that to a percentage, would be 100%. So, what we're going to do is, I'm going to take 9, I'm going to divide 9 by 102, and then I'm going to multiply that by 100 to make this a percentage. So I have, and we're rounding to the nearest tenth, so that's 1 decimal place, so 8.8%. Then here, I'm going to have 26 divided by 102. And the trick here, in order to show this as a percentage, is I'm moving the decimal place 2 spots over. So this is 25.5%. 9 is the same here, so I'm going to use 9 again. Why work harder? Work smarter. 44 divided by 102 is going to be 43.1%. 8 divided by 102 is going to be 7.8%. 26 divided by 102 is 25.5%. Oh, could have worked smarter. Missed opportunity. 23.5%. 17 divided by 102 is 16.7%. 52 divided by 102 is 50, and when we round this, we should actually have 51.0%, which would make sense, because 25.5 plus 25.5 is 51.0. Good. And then 33 divided by 102 is 23.4. No. If we added these, it would be 23.3. We're going to go 23.3%. Okay. And then 58 divided by 102 is going to be 56.9%. And we can check to know that we're right, because 43.1 plus 56.9 is 100. Perfect. And then these three numbers will add up to 100. Nice. Okay. So we've done part 1. We've calculated the relative frequencies for the table above and written them as a percentage with 1 decimal spot. Okay. Now we have a couple questions. Number 2 says, what is the relative frequency for the carpool category? Write a sentence interpreting this value in the context of school transportation. So for the carpool category, the relative frequency is 32.3%. And I'm using the total because they're not specifying whether the carpooler is male or female. It's the frequency for the carpool category. So the whole carpool category would be 32.3%. So in a sentence, I would say 32.3% of students use a carpool to get to school. So a relative frequency is always a percent of some value, right? So the same thing was happening with our ice cream. This was percent of students. So anytime we say percent, we want to say of what? A percent of students, a percent of men, a percent of women, something like that. Okay. Number 3, what is the proportion of students who are female and walk to school? So I'm going to go to female and walk to school. That's going to be 7.8%. Really, since they're asking for a proportion, that decimal would be 0.078. But since they're asking us to write a sentence interpreting this value, I'm going to say 7.8% of students are female and walk to school. Okay. And it's important to write that 7.8% of students are female and walk to school. So this is, we know that 56.9% of students are female, but we're looking at students who are female and walk to school, okay? And we're not saying, okay, 7.8% of the students who walk to school are female. That would be different, because really it looks like almost half of the students that walk to school are female, okay? So it's important, the wording here is very important, the order of these words. All right, finally, number 4, a student is selected at random from this school. What would you predict this student's mode of transportation to be? Explain. Take a second. What do you think? Look at the table. If someone was picked at random, how do you think they get to school? Hopefully you've got a prediction, you paused it. I would predict, if I'm looking at this, I'm looking at the total numbers here. So it looks like almost 17% of students walk to school. 51% of students ride the bus to school. 32% of students carpool. So really, if a student's picked at random, it's most likely that they're going to be riding the bus, because more than half the kids ride the bus to school, right? So I would predict that a randomly selected student will ride the bus to school because I'm going to say because more than half, because more than 50% of students ride the bus to school. Okay, so in the classwork, I'm going to be looking for an answer with some kind of justification like this. All right, good work today. Proud of you for following me through this whole long video. I will see you with the next video.